Good morning, good evening, and good whenever you're listening. Welcome to Astronomy Daily, your front row seat to the cosmos. I'm Anna.
And I'm Avery. It's Friday the 13th, February 2026. And if you're superstitious, well, the universe doesn't care about your calendar. It's been too busy making black holes, breaking rockets, and building planetary systems that make absolutely no sense.
That's right. We've got an absolutely packed show for you today. Astronomers may have just watched a star quietly collapse into a brand new black hole in our neighboring Andromeda galaxy. No supernova required. SpaceX's Crew-12 is launching to the International Space Station as we speak. Europe's most powerful rocket just flew for the very first time. And that's just for starters.
We've also got a Vulcan rocket that apparently didn't learn its lesson the first time around. A planetary system that's been turned completely inside out, and NASA's Swift Observatory going into survival mode to avoid a fiery re-entry. Let's get into it.
We're kicking things off with what is quite literally happening right now. NASA and SpaceX have given the final go for Crew-12 mission to the International Space Station. Liftoff was scheduled for 5:15 a.m. Eastern Time this morning from Space Launch Complex 40 at Cape Canaveral.
The Crew is an international squad. We've got NASA astronauts Jessica Meir and Jack Hathaway, European Space Agency astronauts Sophie Edeneau from France, and Roscosmos cosmonaut Andrei Fedyev from Russia. They're riding aboard a SpaceX Dragon capsule on a Falcon 9 rocket.
And this launch was supposed to happen yesterday on the 12th, but mission teams waved off due to weather conditions along the flight path. They completed a final weather briefing last night and gave the all-clear to proceed into the countdown.
If everything went according to plan this morning, the crew should arrive at the station tomorrow afternoon, on Valentine's Day, at around 3:15 p.m. Eastern. Romantic, right? Nothing says I love you like docking with a space station at 28,000 kilometers per hour.
Once they're aboard, they'll bring the station back up to its full complement of 7 crew members. The ISS has been operating with a reduced crew, so this is a welcome reinforcement. They've got a packed science agenda waiting for them up there.
Fun stat on this one, the Falcon 9 booster being used, B1081, is flying for its 22nd time. 22 flights on a single rocket booster, and this is the 19th Falcon 9 mission of 2026 alone, and we're only in mid-February. SpaceX's launch cadence is just relentless.
We'll keep you updated on Crew-12's progress as they make their way to the station. You can catch the full coverage on NASA Plus, Amazon Prime, and NASA's YouTube channel.
All right, Anna, this next story is the kind of thing that gives astrophysicists goosebumps. Astronomers believe they've witnessed something extraordinary. A massive star in the Andromeda galaxy that didn't go out by a bang, but just quietly vanished. And what it left behind appears to be a brand new black hole.
This is genuinely remarkable. The star, cataloged as M31 2014 DS1, was a yellow supergiant, about 13 times the mass of our own sun, sitting roughly 2.5 million light-years away in our neighboring Andromeda galaxy. Before it disappeared, it was one of the brightest stars in Andromeda, shining about 100,000 times brighter than our own sun.
So here's what happened. A team led by Columbia University astrophysicist Keisha Day was sifting through archival data from NASA's NEOWISE mission, an infrared space telescope that mapped the sky from 2009 to 2024. They were building a map of how millions of stars change in brightness over time. And buried in that data, they found something stunning.
Starting around 2014, this star began to brighten in infrared light. Then it started fading dramatically in visible light, and by 2022, it had vanished entirely from NEOWISE's view. Even with the most sensitive telescopes available today, there's nothing there. As DePass put it, imagine if Betelgeuse just suddenly disappeared. That's essentially what happened here, just in the galaxy next door.
Now, normally when a massive star dies, it goes out spectacularly as a supernova. The core collapses, neutrinos erupt outward, and the resulting shockwave blasts the star's outer layers into space in an explosion that can outshine an entire galaxy. But this star didn't do any of that. It appears to be what astronomers call a failed supernova.
The theory is that the core collapsed as expected, forming a dense neutron star, But the shock wave that was supposed to blow the star apart just wasn't strong enough. Instead of exploding outward, most of the star's material fell back inward, overwhelming the neutron star and creating a black hole. It's death by implosion rather than explosion.
And what's really interesting is the role of convection. The team realized that previous models hadn't properly accounted for the churning, turbulent motions in the star's outer layers. When they factored that in, they found the convection actually helps sap energy from the shockwave, making it more likely to fail. That's a significant new insight.
The material that didn't fall straight in is now forming a rotating accretion disk around the newborn black hole, slowly spiraling inward, much like water circling a drain. The infrared glow from that debris should remain visible to the James Webb Space Telescope for decades as it gradually fades.
The study was published yesterday in the journal Science, and the implications are huge. If relatively lightweight stars like this one, at just 13 solar masses, can collapse directly into black holes, then there could be far more black holes out there than we've previously estimated. This could be a very common way for stars to die, and we've just been missing it because there's no explosion to see.
Not everyone's convinced yet, though. Some astronomers suggest this could be a case of merging stars whose combined light got obscured by dust. But as one researcher put it, the definitive test is simple. Death is forever. If it's truly a black hole, that star is never coming back. Future observations with JWST will help settle the debate.
Sticking with the launch theme, Europe had a huge milestone yesterday. The most powerful version of the Ariane 6 rocket flew for the first time, and it was carrying cargo for one of SpaceX's biggest competitors.
That's right. Arianespace launched the Ariane 64, the 4-booster configuration of Europe's new flagship rocket. It lifted off from the Guyana Space Center in Kourou, French Guyana, at 1645 UTC on February 12th, and riding on top were 32 satellites for Amazon's internet constellation, now officially branded as Amazon LEO.
So let's break down the naming. The Ariane 6 comes in two versions, the 6.2 with 2 strap-on solid rocket boosters and the 6.4 with 4. This was the first time the 6.4 has ever flown, and it's significantly more powerful. Those 4 P120C solid boosters give it the extra punch needed to loft heavier payloads.
And Amazon LEO, formerly known as Project Kuiper, is Amazon's answer to SpaceX's Starlink. The plan is to build a constellation of 3,236 satellites providing broadband internet from low Earth orbit. So these 32 satellites are an early batch to start building out that network.
It's a big deal on two fronts. For Europe, the Ariane 6.4 flying successfully means they now have a heavy lift option that can compete for larger commercial and government payloads. And for Amazon, getting satellites up on a non-SpaceX rocket is strategically important. You don't want your main competitor also being your sole ride to orbit.
The launch went smoothly, with the satellites successfully deployed into low Earth orbit. It's a promising start for the Ariane 6.4 configuration.
Now, speaking of rockets that had a slightly less smooth day, we need to talk about the Vulcan Centaur. This is an update to the story we covered yesterday. United Launch Alliance flew the USSF-87 mission for the U.S. Space Force early on February 12th, and there was a very familiar problem.
About 30 seconds after liftoff from Cape Canaveral, observers noticed a bright glow and a shower of sparks pouring from the aft end of one of the 4 GEM 63XL solid rocket boosters. Video and tracking footage showed what appears to be a nozzle burn-through, where hot exhaust gas essentially melts its way through the nozzle casing.
And here's the thing. This has happened before. The exact same type of anomaly occurred during Vulcan's second certification flight back in October 2024. ULA and booster manufacturer Northrop Grumman spent months investigating that incident, identified a manufacturing defect, and said they'd fixed it. The third flight in August 2025 went cleanly.
But now, on just the 4th flight overall, the problem is back. ULA acknowledged it had, quote, an observation early during flight on one of the 4 solid rocket motors, and said the team is reviewing the data.
The silver lining is that the mission still succeeded. The the Vulcan's twin BE-4 main engines compensated, and the Centaur upper stage completed all its planned burns. About 8 hours after launch, ULA confirmed the payloads were successfully delivered to geosynchronous orbit, more than 22,000 miles above Earth.
The primary payload was a pair of GSS-AP satellites for the Space Force. These are maneuverable spacecraft that serve as a sort of neighborhood watch for geosynchronous orbit, monitoring activity near U.S. and allied assets. There were also some research and development payloads aboard.
But the bigger question now is what this means for Vulcan's future. ULA had ambitious plans to fly 16 to 18 missions this year, including launches for Amazon, GPS satellites, and more Space Force payloads. A recurring booster issue on a rocket that's only flown 4 times is a serious concern. The Space Force has already said it will work closely with ULA on flight worthiness before the next national security mission.
We'll be watching this one closely. Vulcan is supposed to be ULA's flagship for the future, replacing the venerable Atlas V. It needs to prove it can fly reliably, and a pattern of booster issues isn't helping that case.
All right, time for some planetary weirdness. Astronomers have found a star system that looks like someone assembled the planets in the wrong order. Think of it as a cosmic double-stuffed Oreo.
That's actually a great analogy. The star is called LHS 1903. It's a red dwarf about half the mass of our sun, located about 116 light-years away. It has 4 planets, all orbiting in less than 30 days, so it's a very compact system. And from the star outward, the arrangement goes rocky, gaseous, gaseous, rocky.
Which is the exact opposite of what models predict. In standard planetary formation theory, rocky planets form closer to the star where intense starlight strips away atmospheres. And gas giants form farther out, where there's more gas available in the protoplanetary disk. You'd expect rocky on the inside, gassy on the outside.
But LHS 1903 follows the rules beautifully for the first 3 planets, a rocky one closest in, then 2 gaseous ones. And then the 4th planet, the one furthest out, is rocky again. It's like finding a Venus-like world out past Neptune's orbit. It just shouldn't be there.
The system was first discovered by NASA's TESS mission back in 2019, and this latest study, published February 12th in Science, used a suite of ground-based and space-based instruments to precisely determine the planet's masses and densities. That's how they could tell which ones are rocky and which have thick gaseous envelopes.
The leading explanation is planetary migration. Sometime early in the system's history, the inner planets may have shuffled around, similar to what happened in our own solar system during the late heavy bombardment. A gravitational reshuffle could have sent a large body crashing into the 4th planet, stripping away its atmosphere, or the planet may have formed late, after the system had run out of gas.
As astronomer Andrew Cameron from the University of St. Andrews put it, that stuff does happen in young planetary systems. This one has the look of something that's been turned inside out. It's a fantastic reminder that for all our models and theories, the universe keeps finding ways to surprise us.
Our final story today is about a veteran space telescope that's fighting for its life and NASA's creative plan to save it.
The Neil Gerald Swift Observatory has been one of NASA's workhorses for high-energy astrophysics. It's been in orbit for about 21 years, rapidly slewing to observe gamma-ray bursts and other transient cosmic events. But time and physics are catching up with it.
The problem is atmospheric drag, enhanced solar activity, and we're right around solar maximum, heats Earth's upper atmosphere and causes it to expand. That expanded atmosphere creates more drag on satellites in low orbit, slowly pulling them down. Swift's average altitude has been steadily declining, and it's now dropped below about 250 miles or 400 kilometers.
So on February 11th, NASA's Swift team made a tough call. They've temporarily suspended most science operations. The Burst Alert telescope will keep detecting gamma-ray bursts, but the spacecraft will no longer slew to follow up on those detections with its other instruments. Instead, controllers are keeping Swift in a fixed orientation that minimizes atmospheric drag.
Think of it like a swimmer turning sideways to cut through a current instead of facing it head-on. By reducing how much surface area Swift presents to the thin wisps of atmosphere at that altitude, they can slow the orbital decay.
And here's the creative part. NASA has contracted a company called Catalyst Space Technologies, based in Flagstaff, Arizona, to actually go up and give Swift a push. They're planning a servicing mission that will boost the observatory into a higher orbit, extending its scientific lifetime.
The Reboost spacecraft is expected to launch in the summer, but for that to work, Swift needs to stay above about 185 miles, roughly 300 kilometers. So everything they're doing now is about preserving enough altitude to make the rescue mission possible.
It's a fascinating case study in satellite servicing. If it works, it demonstrates a capability that could be applied to all sorts of aging spacecraft. Rather than letting valuable observatories burn up, you send a little tugboat to push them back up. The economics of that could be transformative for space science.
We're rooting for Swift, 21 years of service and still going. Fingers crossed the Reboost mission comes together in time.
And that wraps up another packed edition of Astronomy Daily. What a Friday the 13th it's been, from a star silently becoming a black hole to rockets that keep surprising us. The universe never takes a day off.
If you enjoyed today's episode, please hit subscribe wherever you're listening and leave us a review if you can. It really does help new listeners find us. You can also follow us on social media at Astro Daily Pod on all the major platforms.
Head over to astronomydaily.io for full show notes and links to all the stories we covered today. And if you've got questions, story tips, or just want to say hi, we'd love to hear from you.
Until next time, keep looking up.
Clear skies, everyone.
Astronomy.